Hi everyone, this is Miss Nichols, and this video is on the first equation of the year, which is called the motion equation, and also on some of the algebra tools that you'll be using to solve equations. It's a pretty long slideshow, probably the longest one of this unit. However, if you are very comfortable in math, you probably can just watch the first bit of it through the motion equation if you feel like you already can use algebra to solve equations. If math is not your favorite subject and you feel like it's something you need to work on, this is perhaps going to be the most important video of the year to really pay attention to and go back, do some extra practice, come see a teacher if you need it, because this skill will really be useful for you throughout the rest of the year. So make sure you've got dedicated enough time to this video. The essential question is, how can I create an equation that allows me to find the average velocity, the distance traveled by an object, or the amount of time an object is moving? We're going to start off by creating the motion equation. I'm never going to give you an equation in this class and just expect you to accept it, because you'll forget it. And if you don't understand where an equation came from, it won't make sense. You won't find other ways to apply it. So I want you guys to really be able to make your own equations and to understand where equations came from. So we're going to be creating the motion equation during this slideshow. So the first question is, if you wanted to know someone's average velocity, you wanted to know how fast someone or something was going, what two other things would you have to find out or measure in order to know this? If you think back to the definition of velocity, it's how many meters an object is traveling every second. That should tell you a hint about what we're looking for. So the two things that I kind of mentioned in that definition were the distance the object is traveling, or delta D, and the amount of time that it took to cover that distance, which is delta T. So now that we know which two other variables are going to be in this equation with V average, we have to think about what are the mathematical relationships between those independent variables and the dependent variable. So I would have you do a little thought experiment with me here. Imagine that we have two cars, and one car travels a longer distance in an hour, and the other car travels a shorter distance in an hour. Which car is going to have an average velocity that is higher, the one that went a bigger delta D or the one that went a smaller delta D? Hopefully, that's pretty obvious to you that the bigger the delta D, the bigger the velocity, assuming the time is the same, which tells me that there is going to be a linear relationship between delta D and V average. This idea is going to be crucial to creating the equation in a minute. Second thought experiment. Now we have two girls running a race. And one girl takes a large amount of time to run 100 meters, and the other girl takes a small amount of time to run 100 meters. Which girl ran the race faster? The one that took an hour to run it, or the one that took 5 minutes to run it? Again, if you think about it for a minute, hopefully it'll make sense to you that the bigger the amount of time it takes you to do something, the smaller the velocity of the object is. In other words, there is an inverse relationship between delta T and the average velocity of an object. So the last step is to actually use those relationships to build our equation. If you think back or look back in your notes to the video where we talked about building equations, you'll remember that the first thing that we do is we put the dependent variable on one side of the equal sign. So we'll have V average equals, why don't you follow along with me, V average equals, and then on the other side we put all of our linear relationships on the top, right? So we have one linear relationship, we have delta D is linear, so that goes on the top of the fraction, and then we put all of our inverse relationships on the bottom, or the denominator of the fraction. So we'll put our delta T on the bottom. Hopefully, if you followed along correctly, you ended up with this equation, V average equals delta D over delta T, and that is our first equation of the year. We're going to call it the motion equation because it lets us calculate any of those variables if you know the other two. A really quick note about this, you may have used some form of this equation before, but it probably didn't have those little math operators, the average and the delta in there. Those are super important in physics. And the reason that they're super important is because without them, your equation doesn't work at all, actually, if you're careful. The average part, the v-average part, tells me that during an object's motion, its velocity is probably not going to be exactly the same the entire time. Like if you drive to Salem, you're not going to be going the same speed the entire trip. All this equation is going to tell you is what is my average speed during that time interval, not what is the actual velocity of the car at any moment. And the deltas make a difference because we don't actually care what the distance of the object is, like where it's located. I don't care if it's at the 50-yard line or in Japan. What I care about is how much distance changes, so how much distance it covers during a specific amount of time. Same thing with the time. It's how much time is changing as that object is moving. So it's going to be crucial that you write this equation with those math operators, and when you plug in values to this equation, you can't just plug in any old d or t. You have to actually specifically look for the delta d and the delta t, which will help you calculate the average velocity. Okay, so now that we have our first motion equation, we're going to be talking a little bit about how to use that to solve for any of those variables. As I mentioned earlier, if you're someone that feels really comfortable with math, that you feel like you could solve a word problem and solve for any variable in an equation very easily, you probably can either fast forward through the rest of this or skip it entirely. But if you are someone that is a little bit more nervous about math, or it's not your favorite subject, or you're not sure how to solve an equation, please do go through the rest of this video carefully and come and get help if it doesn't make sense to you. Because this will be tested. This is one of your proficiencies. Can you identify what equation to use, plug the correct values in, and solve for any wanted variable in an equation? In every unit, we'll be showing you some tips and tricks that allow you to think and solve problems a little bit more like a physicist. And one of the tools that I use all the time is called a no-want list. The idea with the no-want list is it's something that helps you keep track of all the information that you have in the word problem so that you can figure out what equation to use to solve for whatever you'd like to know. So the first thing that you need to be able to do is to identify variables and their values and their units in order to put them into the no-want list. So we practiced this a long time ago on the very first video, in fact. But you should be able to read a problem like this. A ball rolls for 5 seconds, it travels 10 meters, what's its average velocity? And figure out what variables each sentence is talking about. What I do with those variables is I put them into a list where one column is the things that I know and the next column is the things that I want. When you put something in the list, you want to be really careful to write the name of or the letter, the symbol that represents the variable, and the value and the units. So for example, I would say delta t equals 5 seconds is the first thing I know, right? That's a time because we know it's got units of time. So, and it's the amount of time that's changing during the ball rolling. So it's delta t is 5 seconds. The next piece, it travels 10 meters. Again, that's the amount of distance that the ball changes by, so it's a delta d equals 10 meters. And then the last bit is the thing that we want, which is the average velocity, and that's what the question asks pretty clearly. So we've now generated a list of all the things that we know and also the thing that we want to know. Now that we've got our no-want list, the next thing to do is to choose an equation. As a reminder, every equation that you'll need in this class will always be given to you on tests and in your notebooks. So you don't need to stress out about memorizing them, but you do still need to figure out which one to use. So the key thing is that you're looking for an equation that has, for sure, the variable that you want to know in it, because if it doesn't have that, then there's no way you can find it. And then ideally, it's got as many of the known variables as you have as possible, because the closer we can get to having all the information in the equation, the better off we're going to be. Once you find that equation, you're going to write it down just like it looks on the reference sheet. So obviously right now we only have one equation. That's going to be the one we're going to be using, but it should make sense that this equation has v-average in it, which is our wanted value, and it also has both of the known values. It has delta d and delta t in it, so that makes this a really good equation to use. So you'll write it down just like that. The next step is plugging in the values that you know. So right underneath the equation that you wrote, you're going to write that equation again, but this time for every variable that you know, instead of writing the variable symbol, you will write the value. So this is the equation we started with, and this is what the equation looks like with those values plugged in, right? We knew delta D was equal to 10 meters, so instead of writing delta D, I can write 10 meters. We knew delta T was equal to 5 seconds, so instead of writing delta T, we're going to write 5 seconds. We don't know anything about V average yet, so we have to leave that just like it is. So we leave a V average in that equation. So this is the equation with all the values plugged in. The last step is the simplify or solve step. This is the step that you're going to use to actually arrive at an answer. So the goal of this step is to kind of get that unknown or the wanted variable all by itself on one side of the equal sign with a single number on the other side of the equal sign, and then we'll have the value. Incidentally, we would really prefer decimal answers in physics because they're kind of easier to picture in the real world, so no fractions. And you want to make sure that when you're done simplifying, your final answer has units on it. Otherwise, it's not really an answer. So we had that equation from the last step, V average equals 10 meters divided by 5 seconds. So all we have to do to simplify this one, it's got the V average already alone on one side of the equal sign. All we have to do is take that 10 and divide it by 5, and we get 2. And we take meters divided by seconds, and we get our new unit, which is meters every second. So it's very convenient how both the number values and the units can actually do the same sort of math process to arrive at your answer. So the answer in this case is 2 meters per second. If you end up with an equation that looks kind of funny and you've got your values all plugged in, but you're just not quite sure how to get that variable, that last wanted variable by itself, often you're going to want to use cross multiplication, which you probably have learned about in another math class before. But I'm going to give you a refresher of how to do that. If you feel like you really know how to do cross multiplication, don't worry about this. You can fast forward through the video. But if you're not, you're going to want to pay good attention to this piece. So let's assume that we have a different equation. We've already gone through our no want list. We've already plugged it in. Our equation looks like this with all the values plugged in. 6 meters per second equals 24 meters divided by delta t, right? So we know our velocity, we know our distance. We're trying to solve for the amount of time it takes. This is a little bit trickier because the delta t isn't all alone on one side of the equal sign, and we have to get it all alone before we actually finish the problem. So let's see what kinds of steps we can take. So the first step is to make both sides of the equation into a fraction. I know this kind of feels like you're going backwards, but it's going to make things easier in the long run. So instead of leaving that 6 meters per second all by itself, I'm going to make it 6 meters per second over 1. And then we already had a fraction on the other side, which is 24 meters divided by delta t. So the reason that we do that is because then we're going to be multiplying together the values that are diagonal from each other and making a new equation where my two new multiplied values are equal to each other. So for example, 6 meters per second is diagonal from delta t. So 6 meters per second times delta t is 6 delta t. And 1 times 24 meters is going to be 24 meters, right? So we rewrite our new equation with those two new multiplied out values, 6 meters per second times delta t equals 2 meters times 1. So we're a lot closer now to getting that equation solved because we don't have that delta t on the bottom of a fraction. This makes it easier for you to see how to get it all alone. But we still have one more step to take to get the delta t all alone. Right? We look at the equation, we try to figure out what is keeping the delta t from being all alone, and in this case it's that 6 meters per second that's on the same side as delta t, so we got to get rid of that 6 meters per second before delta t can be all alone. And in this case what we're going to be doing is dividing both sides by 6 meters per second, because that allows me to cancel out the 6 meters per second that's on the same side as the delta t, leaving delta t all by itself. On the other side of the fraction, we're just going to do our math just like we did when we solved for our fraction earlier in the slideshow. We've got 24 times 1 divided by 6, which is going to simplify to 4, but you could put it in a calculator if you want. And then I have meters divided by meters every second, which actually gives you seconds because the meters are going to cancel out as well. So we're left with our solved final equation is delta t is equal to 4 seconds. If that lost you anywhere in the last few slides, please do come in at tutor time and get help from any of the teachers, and we'll run you through some practice problems and samples to make sure that you're comfortable with this skill. We made it through the longest slideshow of this unit. Quick, take a few minutes to summarize, just kind of process the information that we've come up with and think about what parts of it were easy for you and what parts you might need help with. The essential question was, how can I create an equation that allows me to find the average velocity, the distance traveled, or the time an object is moving? Thanks for watching.